Hello, everyone. I guess you're getting kind of hungry. It's just right before lunch. We're going to discuss type theory and machine learning, so unfortunately, I'll have to take my time. But today we're going to discuss how we can make our JavaScript bundler a bit smarter. Currently, I'm co-founder and CTO at Rime.com, whereby using virtualization in the browser, we are trying to help you build more scalable and consistent workshops and corporate trainings. In my spare time, I'm also doing open source, so former member of the Angular mobile team. I've been authoring the Angular style guide. I've been working on Colorizer, Angular Seed, and a few other open source projects. And I have written books about Angular. Actually, in fact, only one book. This creates the illusion that I have written several. It just has 3 editions. So if you're getting started with the framework, it might be a good fit for you. The talk is called Teach Your Bundler the User's Habits. For the purpose, we're going to apply some algorithms, some ideas from the machine learning. So I was thinking that maybe eventually more appropriate title would be ML-driven bundling. However, in the core of everything is going to be the data for how our users are using the application. So even a better title would be data-driven bundling with less buzzwords, but more accurate. We all know that JavaScript is very powerful, right? This game here was released by the Google Chrome team, I think. And you can control your lightsaber by using your mobile device. With JavaScript, we have some awesome APIs out there. We have API for WebRTC, where we can create audio and video conferencing in the browser. We have WebGL in this case, where we can create even VR experiences. And all of this is with speed very close to native. So JavaScript is getting faster and faster recently. Unfortunately, we want to take advantage of all these awesome APIs in order to provide great user experiences. So what happens is that, well, everything comes with a price tag. How many of you have played Doom? Yeah. Well, since 2016, the average web app size is bigger than the Doom install image. So we're providing more and more assets of our users. And, well, on 3G network, downloading a web app is taking about 19 seconds. And this is pretty bad user experience. The drop rate of our users and respectively our conversion is going to drop linearly to this. So let me just show you how much these 19 seconds actually are. Imagine that my blog was actually taking 19 seconds to load. So everything that you would see over when you open the page before you see actually content is going to be something like this. It's terrible, isn't it? And these were only about 10 seconds. So in general, we're just stressing out our users. It is proven that waiting for a slow web app to load is taking about the same amount of stress as watching a horror movie. And JavaScript on top of that is very expensive as well. Adios Mani published a very interesting article where he showed how decoding and rasterization of a JPG image, which is 170 kilobytes big, is much lighter compared to processing a large amount of JavaScript because of the phases of lexical analysis, syntax analysis, and after that execution of our JavaScript. So what we usually do in order to just speed up our user experience is apply lazy loading. Initially, we provide the minimum amount of assets for the users required to open given web app. And right after that, on demand, we incrementally just provide them the other assets that they may need for the other pages or other widgets. And there are 2 main strategies for doing that. We have route-based strategy, route-based code splitting, where we're just splitting our application's JavaScript based on the route's transitions. So each individual route in our application, each individual page, has its own small chunk of JavaScript. We also have component-based code splitting, where we can even apply code splitting on even smaller level of granularity. So if we have a widget which is not very frequently used by the users, we can just delay its loading and put it into a lazy loaded chunk. So when the user intends to use it, well, we can just provide this bundle and download it from the network. But now let's focus on the route-based code splitting. How do we usually pick the split points for this? From what I have observed and what I have done, unfortunately, it's mostly subjective. I just think that the user may eventually not go to given page the first time when they visit the application. So I'm delaying the loss of this specific chunk corresponding to the route that I think that the users may eventually not open. And sometimes it is based on data, where we look at some reports, and we figure out that we can eventually delay the loading of some JavaScript. But always, after we have this data, we're applying a very manual and error-prone approach. In order to load some bundles lazily, we'll have to just change static imports to dynamic imports. And right after that, once we change the UX of our app or just the user behavior changes, we will have to go there, go to the source code, and update it accordingly. Another techniques for speeding up our applications is prefetching. So with prefetching, we just fetch in advance some content that the user may need in future. Let's say that we're at page A, and the user can go afterwards to either page B, C, or D. So we need to somehow prioritize these pages in order to download the assets only from the pages which are actually going to have the highest probability to be open, right? And what I have noticed is that, well, often these priorities are being picked on random, or just according to our own understanding of the user's behavior. And trying to guess how our users behave, it's not usually the best possible thing to do. So my suggestion is just to lazy load everything, just apply code splitting for each individual route of our application, and just let the tooling take care of the rest. Yeah, how many of you are using Google Analytics? Yeah, almost all of us, right? So with Google Analytics, by using their API, we can get a navigation graph similar to this one here. So the individual nodes here in the graph are the pages in our application. We have transitions between them. The thicker given arrow, the given edge here is, the higher the probability for the user to perform the transition is as well. So based on the thickness of these arrows here, we can cluster the individual nodes into 3 separate bundles. We can, for instance, cluster the A routes here into the A chunks here into one common chunk, like let's say a.bundle.js. We can cluster the B chunks into b.bundle.js and leave the root into a separate chunk. And on top of that, while the user is navigating in our application, we can track the possible transitions from given point. So if let's say that the user is at /A. From the graph here, we can see that, well, the only route that the user can visit next, which is not part of the already downloaded bundle associated with the A route, is /B. So we can just prefetch /B, and yeah, let just the users have better user experience this way. So yeah, I'm just going to introduce an approach which is just automating these two techniques by using Webpack. And in order to apply it into a real-life application, I used an app that I worked some time back. It's called Brownie Points. It is an educational application for kids. It has a lot of nested routing and a lot of assets. And also it has some data from Google Analytics. So this is basically the navigation, actually the page graph that I got from Google Analytics by doing some API calls there. Unfortunately, I wasn't able to release the entire source code of Brownie Points. So I put all my design skills together and developed this clone here, where you have route-based splitting. So each individual page here is loaded lazily. And this application is developed in both Angular and React, so we can use the same technique for both frameworks by using the official tooling. And the official tooling, respectively for Angular, this is the Angular CLI. For React, it is create React app. In both cases, we can build the application by using npm run build, which after that is going to output all the assets into either build for create React app or dist for Angular CLI. After we serve these assets to the browser and emulate really bad conditions, by really bad conditions, I mean really bad conditions, let's say 1500 milliseconds of latency and 50 kilobits per second download speed, we are going to have pretty poor experience, right? So let's suppose that from the current page we want to go to settings. Our users have to wait for a bit in order to get the settings page. If they want to navigate to home, oops, excuse me. If they want to go to home, they'll have to wait 1,500 milliseconds as well. And for the FAQ, the same is going to happen again. Of course, we can do some optimizations here. For instance, we can group all the JavaScript into a single bundle. And by doing that, of course, well, we're going to hit another limitation, the limited bandwidth that we have. If we take a look at the Google Analytics graph, we can notice, well, there are a lot of patterns here. It's such a mess here, like such a messy network. But if we look specifically in this part of the graph, we can see that there is direct, very thick connection between the main page and the settings page, and also between the home page and the FAQ page as well. So two possible optimizations that we can perform are just, well, place main and settings into the same chunk eventually, and prefetch FAQ when the user is in the home page. Unfortunately, for both things, we'll have to apply some manual logic. For instance, in order to have main and settings into the same chunk, we can eventually use static imports compared to dynamic ones. And in order to prefetch the FAQ page from home, what we'll have to do is just add some custom piece of logic where we are dynamically importing FAQ from there. So I want to show you a tool that I've been working on over the past couple of weeks. It is a tool for data-driven bundling. It is very early preview yet, but well, you can use it in your Angular applications and to some extent in your React apps. In order to use it, just use npm run eject. So this is going to just output your configuration, your Webpack config for both starters, for both CLI tools, Angular CLI and Create React App. And after that, you should edit the Webpack config that you got. And well, just add a single line of JavaScript there by introducing the ML plugin, and with some almost zero configuration. Also, this data property here is actually the data that we got from Google Analytics. The plugin can perform everything else automatically for you. So here is the result. The user navigates to settings, and they get instant experience because settings is already part of main. After that, they go to home. Here they should wait a little bit because this wasn't part of the frequent navigation behavior that we noticed from Google Analytics. But when they go to home, notice how we are prefetching FAQ. So when they go to FAQ, they're instantly getting the page there because it's already in the cache. Now let's take a look at how this actually works. We're not going to dig into too much technical details. We're going to take a look at the tools which are making this all work together. We have the Google Analytics package, which just fetches some structured, aggregated data from Google Analytics. We have the parser, which parser is collecting some metadata out of our application by using static analysis. We have the Webpack package, which has a set of Webpack plugins internally. And we have a package which performs clustering on top of the chunks based on some strongly connected component graph related algorithms. So let's take a look at the Google Analytics package first. So I said it fetches structured information from Google Analytics and also aggregated information. Well, this is because of the fact that Google Analytics doesn't know about our route definitions. So we may have parameters in our routes, and Google Analytics is not going to be aware of that. So we're going to see these as separate nodes in the graph, and we definitely do not want that. By combining the Google Analytics package and the parser, we're able to get an aggregated page graph for our app. And we can use this GA package just by importing the fetch method, the fetch function from there, passing the private key that we got from the Google Developer Console, passing a view ID for the application that we actually want to extract data for, passing a period, start and end date, and the route declarations. So again, these route declarations, they're actually coming from the parser, which goes through our application, statically analyzes the source code, and right after that figures out what route declarations are related to which specific entry points of the chunks that we have in our app. The next tool, it is the Webpack plugin, which actually has 3 plugins internally. So we have the ML plugin, which is a facade on top of the cluster chunks plugin, and runtime prefetch plugin. What we saw previously was just invoking these 2 plugins internally. The cluster chunks plugin is going to take this page graph that we built from Google Analytics, together with the metadata that we got from the parser, and it is going to figure out how exactly we should group the individual chunks together. So in this specific case, it is going to figure out that all the A routes should go into the A bundle.js, all the B routes should go to the B bundle.js, and the root, respectively, should go to root.bundle.js. Right after that, the runtime prefetch plugin is going to run. It is going to already know the current bundle layout. So based on it, and based on the probabilities for the user to go somewhere else, it is going to do the actual prefetching. Here we are using super basic model. We're just building a Markov chain where each individual row in the matrix that you see, it corresponds to a route from our to a node, like just to a page in our application. And for each row, we also have the probabilities for the user to navigate to a different page in the app. Let's just track a simple flow of navigation flow for the user and see how this is going to behave. And set a probability threshold of 0.5. So we're not going to prefetch anything which has less than 0.5 probability to be visited. So first, the user is in the root. So we are just going to take a look at the first row of the matrix. We're going to see that there is /b, which has 0.7 probability to be visited. So what we're going to do is just download b.bundle.js. Right after that, let's say that the user is following our navigation prediction. We're going to /b. We're going to take a look at the corresponding row in the matrix. We can notice that there is one probability for the user to go to /b/a, but fortunately, /b/a is already part of the same bundle. So we're not going to do anything in this case here. And finally, let's say the user goes to /b/a. In this case, there is one probability which is equal to 1 for the user to go to /a. So in this case, we can just prefetch /a, and this way we have already the entire application into the cache, and the user have had eventually a good experience if we have built the right model based on their behavior. So this project is kind of ambitious. It has a lot of future plans. I have a lot of future plans for it. Imagine we are able to build we are able to provide a personalized build of our application for each individual user. Of course, this is going to require a lot of computational power, right? But still, we can cluster our users. We can apply clustering on our set of users based on their navigation behavior. And for each individual cluster, we can provide a build for our app. We can also apply more smart clustering. So we can also consider the bundle size. If given bundle gets bigger than we want it to be, we can just not cluster it any further with different chunks. Also, more advanced machine learning model will benefit this plugin here in order to perform less overfetching. Because depending on the probability threshold, we can fetch more bundles than actually required. Currently, the plugin has this adaptive nature, where depending on your network connection, it is going to set different probability threshold. So if you're on a slow 2G network, we're going to perform less prefetching compared to if you're on an LTE network, let's say. But we can also consider the user's navigation behavior. So we can apply more advanced model in order to not consider only the current state the user is in. And of course, more robust parser. So currently, the parser, which collects the metadata out of our applications, for Angular it works pretty well because of the entire parsing infrastructure built by the Angular compiler. For React, it is a little bit more inaccurate, and also we can use this with Vue as well. So this is a parser that I'm going to be working on in the near future as well. Based on this article, based on this topic, I published a blog post which has a lot of text. It's about 30-minute read. I struggle reading it every time when I want to make fixes in it. So you can find it here in the references section. It's the first link. You can also take a look at the predictive prefetching, which is something that Adios Manning published recently. And well, with all this research going on in this direction, I'm pretty sure that in the near future, the JavaScript and the web tooling is going to go into a data-driven direction. So our predictions for the user's behavior are going to get much more accurate. Thank you very much for your attention.